The broadcast is now starting. All attendees are in listen-only mode.
Good morning and welcome everyone. My name is Pete Will and I'm Esri's Principal Account Manager to the mining industry. I'm talking to you today from my Esri offices in Broomfield, Colorado, and it's my pleasure to welcome you to this webinar organized in concert with the Esri Mining User Group. Today's webinar is entitled Driving Efficiencies for Mining, Exploring the Analysis Toolbox and Mining Workflows using ArcGIS Pro. This webinar is being recorded and the recording will be posted in the next few days. And as a participant, you'll receive a follow-up email with a link to the recording. As is tradition with other Esri GoToWebinars, we will follow our normal practice of encouraging you to enter questions as we go along in the GoToWebinar questions dialog box. We will answer as many questions as time permits, and any questions we don't get to will be answered in a follow-up email. I'll be your MC for the webinar, and so now let's go ahead and introduce the other webinar participants that you'll be hearing from. Joining us today is Chris Franks with Freeport-McMoRan. Chris is talking to us from his office in Phoenix, Arizona, and Chris is the principal committee lead for our, committee lead for our Esri Mining User Group. Also joining us today and presenting the key materials are Matt Ballard and Sarah Deschamps. Matt is a solution engineer on the Esri Natural Resources team and is based in San Antonio, Texas, while Sarah is a product owner at Sequent and is based in Montreal, Canada. Before we get started, I have asked Chris to say a few words as an introduction to what the mug is all about. Chris?
Thank you, Pete, and good morning, and thank you for everyone that's out there and has taken time out of their day to attend this webinar. Again, my name is Chris Franks, and I'm just a part of the steering committee for the Esri Mining User Group. Our mission as a group is to facilitate development and the implementation of very business-centric functionality and content between the mining user group, user community, Esri, and the related partner network, such as the presentation you're about to see today. We're a community for professionals that are interested in exploration in the mining industry's use of GIS. We try to facilitate collaboration among the MUG membership using our LinkedIn and other online and social networking tools, of which we are in the process of creating several, and you'll be seeing announcements of those in the upcoming weeks. We also attempt to develop meeting programs, networking opportunities, and socials at the major mining conferences across the globe. We're a volunteer organization. We have corporate sponsors, very generous corporate sponsors that pay our bills. And generally, the steering committee is just intended to provide overall direction and guidance to Esri in the development of products and applications in support of the mining industry. So again, thank you for attending this morning, and I'll turn it back over to Pete.
All right, thank you very much, Chris. Okay, today's discussion is built around ArcGIS Pro. ArcGIS Pro is the latest professional desktop GIS application from Esri. And with ArcGIS Pro, you can explore, visualize, and analyze data. You can create 2D maps and 3D scenes, and then you can share your work to your ArcGIS Online or your ArcGIS Enterprise portal. During the webinar, we'll introduce the vision for ArcGIS Pro as the professional level GIS toolbox. We'll start by highlighting a few recently added capabilities introduced in the most recent release of ArcGIS Pro, and then we'll look at two specific mining-related workflows that shows the depth of analysis that is possible with ArcGIS Pro. The first presentation, Esri will demonstrate how to calculate stockpile volumes and show how the derived data products can be shared with members of your organization through web applications. And then Sequent will present how to visualize drill holes in ArcGIS Pro using their new add-in, which is planned for release this fall. This add-in allows you to import, visualize, and interpret subsurface drilling data sets within ArcGIS Pro. The material we're covering today was derived from conversations with the MUG members and is tailored to help you in understanding the capabilities of ArcGIS Desktop and ArcGIS Pro specifically. We have a lot of material to cover today, so we're going to go ahead and quickly turn it over to Matt and Sarah to fully introduce themselves and to get us started. First up is Matt, and Matt, I'll go ahead and turn it over to you.
All right, thanks, Pete. Like Pete mentioned, my name's Matt Ballard. I'm a solution engineer on Esri's mining team. I work with a lot of our customers to pair our software with business solutions that are in the mining industry. And today, I'll be giving a demonstration where we're going to look at some new features in ArcGIS Pro, which is our ArcGIS Pro 2.4, which is our most recent release. And we're going to look at it in the context of a mining industry workflow, which will be stockpile inventory management. We're going to look at 3 key items. First being imagery and 3D analysis capabilities. Second, tools for making your workflows more efficient. And third, ways for you to share valuable information products with your organization. To start my workflow, I've opened up ArcGIS Pro, where we've recently redesigned the startup experience. At version 2.3, we've added the ability for you to start without a template. So this lets you quickly open a project or a Scratch workspace and choose if you want to save it later. Also, to my left is a list of all of my projects. At the top, though, are my most important projects, which have been pinned to enable quick access. I can go ahead and launch into my webinar project here at the top. In my first map view that we're looking at, we can see some quarry operations. I'm going to zoom into the yard where we've got our stockpiles, and we can start to see where those stockpiles exist. Now, let's zoom in a little bit closer. We can start to see where those stockpiles are. Today, I'll be working with some data that's been provided courtesy of GeoQ, an Esri business partner. And what they've provided to us was some drone imagery, which we use to create this orthomosaic. This orthomosaic that I've added to my map allows me to see in much better resolution the most recent stockpiles that we have. This data could have been processed in any commercial drone processing software, or in this case, we used Esri's drone map. Another product that was generated was this digital surface model. I'm going to be using this digital surface model today to actually calculate the volumes of these stockpiles, but this model can be used for a variety of use cases outside of this. For example, I might be interested in ensuring that all of our stockpiles are safe and stable, or that our roads aren't too steep by looking at a slope map. I might also be working on a reclamation project where I need to calculate how much material will be needed to reclaim an area or a pit. And I want to make sure that this new surface is graded to ensure minimal erosion. To support all of these workflows, I ultimately need to be able to create derivative products from my imagery. In ArcGIS Pro, the way that we do that is with raster functions. I can access these raster functions by clicking imagery at the top in my imagery ribbon, and I can see this raster functions tool. In here, I can search for different products such as slope, and when I choose slope, I have those tools available to me here. I can provide my digital surface model and run. Just like that, I'm able to see very quickly if I zoom into, for example, these 2 stockpiles here, in white areas where there's a high slope that might be causing an instability at some point in the future. Raster functions are essentially operations that are applied to the source raster as opposed to geoprocessing tools, which will write a new output to disk. So this operation is only really applied to the pixels that I can currently see at my current scale and resolution. This enables you to really rapidly create imagery products without creating an excess number of outputs or waiting for the entire product to be written to disk. So as I zoomed in, you notice that the resolution of my product automatically updates because it's processing it just at this specific location. So these functions are very customizable using Python, and they can also be shared to the web for users to use in web applications. Other common ones that are used are for looking at topography data, it might be the contour function. Or if I'm looking at vegetation and I'm interested in understanding the health of it, I might use the normalized difference vegetation indice. And in this case, it would apply to on the fly just like it did there. The one though that I'm going to be using today for my analysis is the shaded relief. With shaded relief, I'm able to really clearly see the boundaries of these stockpiles. Here with this product, you'll really clearly see those edges, and I'm going to use that to actually delineate these stockpiles today for my analysis. So let's talk about actually measuring the volumes. The first way that I'm going to do this is by using our imagery mensuration tools. Mensuration essentially means to measure ground information from imagery. I can access these tools from the top, again from our imagery ribbon. This ribbon interface in ArcGIS Pro makes it a lot easier for you to find tools that are relevant to the data that you're working with. For example, in my table of contents, I've selected a layer that's a raster. It's that shaded relief map. Up at the top in my ribbon interface, you'll notice that I've got tools that are specific to raster layers available to me that are under appearance and data. And under imagery, different tools around classification, or in this case, mensuration that we're going to look at, those are available to me because of the data that I'm selecting. If in my table of contents I select this LAS dataset, I get LAS dataset tools up here at the top, and it grays out the tools that aren't relevant to the data I'm working with. To use these mensuration tools, I'm going to go in here and choose, I could choose, for example, distance or areas, but today I'm interested in volume. When I select volume, I'm able to, from the map, quickly digitize the boundary of a stockpile and double click to finish, and it'll quickly calculate my volume here. I can see over on the right in this panel all of the other previous stockpiles that I've analyzed, and my volumes are there as that cut parameter. So this one that we just measured was 456 cubic meters. Now this is a great way to quickly calculate volumes on the fly, and I can even export this to a report using this button here. But if I have a ton of stockpiles across this entire quarry, if I zoom out, we can see there's lots of them. I don't want to have to do this for every single stockpile. Instead, I want to have a workflow where I can output those volumes to a field within a feature service so that these results can be shared with others as part of a map. For that type of a workflow, we're going to use geoprocessing tools to actually create that analysis. Now, to start with this, I'm going to go to my portal where I know that we've already actually started some of this work. This is one of the biggest reasons why you should be working with ArcGIS Pro. It seamlessly connects to your WebGIS for quick access to your authoritative enterprise data. So from my catalog, I'm logged in at the top right, and I'm able to go to my portal and see a group for stockpile inventory. In here, I know there's a couple of items that are going to help me today in my analysis. First is the stockpiles layer that's already been started by somebody else or myself in my organization. If I zoom in, I'll notice that we've got one stockpile here that's incomplete and one over here that the volumes haven't been measured on. This could be one that I just newly digitized today. The second thing I'm going to be adding from my portal though is this task. By right-clicking on it and adding it to my project here, it opens up a panel on the left, which will help me walk through this workflow. Tasks are a way for you to streamline and document repeatable processes so that you or others in your organization can run through any workflow that you can imagine. As you can see, they're shared with your WebGIS for quick access by anybody who needs them. When I open the task at the top, you'll see it's marked Stockpile Inventory Management, and there's two different tasks underneath it, Calculate Volumes and Calculate Heights. When I choose Calculate Volumes, it's going to take me into this user interface where I can walk through 4 steps. So at the bottom, you'll see this progress bar indicating how many more tasks I have within here. My first step is to digitize any new stockpiles. I'm going to update this one that I can tell is out of date by editing and modifying the vertices on it. Here I can update to reflect what my hillshade is telling me where the boundaries are. And when I'm done with that step, I can go ahead and hit run and next step. My next step is to update the stockpile elevations, and in here, I, as the author of this task, have embedded some geoprocessing tools. In this case, the tool is update feature Z, and it's going to be used to update the elevations of that polygon that I just updated. When I'm done, I'll hit run, and I can continue on to the next step. We'll give it just a minute here to respond, and once we're done, I can hit next step. And in here, my next step is to calculate the stockpile base elevation. Again, this is another geoprocessing tool. I'm going to provide my input features here as the stockpiles, and we'll hit run. Before finally reaching my final step here. What I need to do here is actually calculate the stockpile volumes. We're going to use a tool called polygon volume, and I need to provide an input surface, which is actually going to be an LAS dataset. In this case, the LAS dataset was derived from drone imagery, but it could also be produced from a LiDAR sensor. My input features are those stockpiles. My height field is the average elevation I calculated from the previous step, and I'm calculating the volume above the base plane of the stockpile. I'll go ahead and hit run. It should take just a second here to update the volumes, and we'll see those labels updated with my most recent volumes. So with the new material that's been added to the stockpile, it's now 871 cubic meters. So in just a couple easy steps, I've calculated the updated volumes to the stockpiles, and I didn't need to be a GIS professional going in there and finding which tools to use within the toolboxes. Instead, I was really just provided them directly through that interface. A common question that I get is, what's the difference between model builder and tasks? Tasks are really great for situations where your workflow requires some user interaction, such as digitizing work, or when you want to give users flexibility to skip steps or learn the workflow themselves. Model Builder, on the other hand, is great for when you want to create a single tool that might combine multiple tools and add some custom functionality on top of it. They can be used together to create a highly customized solution. And speaking of Model Builder, there's two new enhancements that came out at 2.4. First, if I go to my catalog over here on the right, at the top, I can see a history of all of my geoprocessing tasks that I've run. We can see I ran update feature Z, add Z information, and polygon volume. If I select all three of these, right click, my third option here is to add to a model. This is going to dynamically create a model builder straight out of that geoprocessing history. So ArcGIS picks up what all the inputs and what all the outputs were for each time you ran those tools, and it automatically ties everything together for you. I can use this model that I just created to select that one stockpile that was out of date, go back to my model, and then we can run this to update that stockpile. So here we see those updates come across pretty quickly. And for a lot of people, give this a second. There we go. So updates coming across, it's 470 cubic meters. Now, for a lot of people, including myself, their first introduction to Python was through exporting from Model Builder and ArcMap. The second enhancement I wanted to highlight with Model Builder is at version 2.4, we introduced that equivalency from ArcMap, which is the ability to export your models to Python so that you can go further and extend this into a Python tool. So from my model at the top, you'll see we've got two options, export to Python file and send to Python window. I can go ahead and do that and go open up my Python file within my files here. So these tools that you just created, whether it's with Model Builder or with Python, they can also be shared as geoprocessing services so your users can run this analysis through web applications. So speaking of sharing, the last item that I want to touch on is different ways for you to distribute this data that we were working with to others in your organization. There's 4 ways I want to look at this. And the first one we're going to look at is the ability for you to use charts. With ArcGIS Pro, you can create charts from your feature layers by going to them in your table of contents, right-clicking on them, and create chart. And here you've got at least 10 different options for everything from bar charts to scatter plots and histograms and profile graphs. Today, I'm interested in understanding the total volumes of each type of stockpile. When I create this bar chart, I can define the properties over here on the right and specify the material as the category, and I want to know the sum of, in this case, the volume. Now, I've got a chart here that's fully interactive, so if I click the pebble material here, it'll update the selection on the map and vice versa. So charts are one great way for you to create these information products, and they can also be exported to different formats to be included in presentations and documents. The second way that I want to show you how you can share is with reports. Reports are a new feature that allow you to configure well-formatted multi-page documents that can summarize or describe your data. When I right-click on that stockpiles layer again, just under Create Chart is New Report. When I choose that, I get a wizard over here on the right side that walks me through the process of creating a report. First, I need to give it a name and select the data source. Second, I need to specify the fields that are in my report and decide which rows to include. I want to include all of my rows, or I could filter by an expression, and I'm interested in understanding the volume and the material again. Thirdly, I can add a grouping. So I want to group based off of volume, and I want to group based off of material, and I want to sort based off of volume descending. So I'm going to see which type of material that we have the most material of. And lastly, I want a summary statistic of the volume being sum. My final step is to do some basic formatting. I'll choose the basic summary with grouping type and hit finish. If you've worked with layouts, this is going to look very familiar to you. And in here, we've got all the different elements of my report. I can click on this header page here, and I'm going to go ahead and insert a logo just to give it a little custom look and feel. Now, there's a whole lot of extra customization that you can start to include, but today I'm just going to accept most of these defaults and go ahead and export from the share ribbon up here at the top. From here, my stockpiles report, which is a PDF now, I can see that logo that we included and a title, and I can see statistics for crushed stone, pebble, and sand, including the total volume of each of those material types, as well as at the bottom, a report on our total volumes across the entire operations. So reports is something that was released at 2.3, but in 2.4, we introduced the ability for you to share these as reporting services for users to generate from web applications. So that's something that, if you're looking for a more advanced workflow where people can do this from the web though, that's something you could look into. The third item for sharing that we're going to look at is layouts. We can't escape looking at ArcGIS Pro without taking just a minute or so to look at layouts. And a new feature that's available is spell check. So this has been a huge request from users in our community. And what I can do is go into this text title here and right-click my spelling errors and quickly adjust them. So this is going to save you a ton of time reviewing your layouts, reducing the possibilities of any typos in any of your products. I can also add elements such as charts from earlier up at the top. So we'll notice that there's an add chart frame. I can select the map that it's associated with, find my chart, and choose an area on my layout to include that. The other thing I'm going to include in my layout is a scene. So within ArcGIS Pro, you can have multiple maps, scenes, and layouts all within the same project, and they're all seamlessly 2D and 3D integrated. So if I want to throw in a 3D scene in this case for a proposed new stockpile location, I can add that to my layout. My layout now shows the status of stockpiles currently, the volumes and what type of materials we have, as well as plans for expanding where we're going to include stockpiles in the future. And finally, the last way I want to share this, and arguably the most effective, is as a web scene. So users can access this as a live interactive map with the most recent information. To do this, I'm going to go to my 3D scene here in my project. And if you recall, those stockpiles that I was working with were coming from my portal. So they had already been shared with the web. I'm referencing them as services, and they're a little bit hidden in here. By looking at this scene, the first thing I notice is that my stockpiles aren't lining up with the elevation. I'm using Esri's elevation data source that's coming from the Living Atlas, which is great for a variety of use cases, but with these really up-to-date, high-resolution stockpiles that I'm working with, it's not going to suffice. So the first thing I'm going to do is correct this. Through my table of contents, I'm going to go to my ground elevation surface and add a new elevation source. I can connect to my portal and go to that stockpile inventory group and find our master elevation dataset. For an organization that has lots of operations, lots of drone flights, the elevation is constantly being updated. This master elevation dataset allows me to catalog all of our most recent elevation data acquisitions so that anybody who's accessing it is always getting the most up-to-date information as we fly new LiDAR, drone, or aerial collections. I'll go ahead and click that layer, hit OK, and it's going to update and refresh the elevations here on my map. I can see now those stockpiles are starting to line up a lot better with where the elevation is according to that master elevation dataset. But I'm also working here with Esri's imagery-based maps. But again, I'm really looking for something much higher resolution. So I'm going to go again to my portal and find this 3D model that I can quickly add to my map. This is going to be a highly performant, really great looking product that's going to work really well in web applications and web scenes. With that, I think I have a valuable information product that's ready to share with my organization. Because I'm leveraging all data that's coming in from the web, when I share my scene, nothing needs to get copied up to a server. So I'm going to go to the share ribbon at the top, choose Webscene, and on the right, it picks up name, summary, and tags coming from my metadata, and I'll just go ahead and hit share. Like I said, because everything's in the web, it should take actually just a matter of seconds for this to be available. It's already done. I can hit Manage Web Scene, and it will open up my web browser where I can see everything that I've just done. Now, as I make modifications and update stockpile volumes on my desktop computer, or if somebody else makes them on their computer, those updates are going to be reflected in here as soon as that analysis is run. So just like that, I've got a web application ready to inform my end users of available stockpile volumes at this facility. In summary, we looked at imagery and 3D analysis capabilities in ArcGIS Pro. You also saw tools for streamlining workflows and making your workflows more efficient. And lastly, we looked at 4 different ways that are new to ArcGIS Pro for you to share and collaborate with others in your organization. All of this in the context of a mining workflow that you can go back and replicate. Now, before I pass it over to Pete, we, in this demonstration looked at quite a few features that were new to 2.3 and 2.4. There's also plenty of features that we didn't have time to go through today, and so I really recommend installing the most recent version and seeing what's new out there to support your workflows. And just to give you a little sneak peek into what's coming in the future for ArcGIS Pro, there's a lot coming down the line that I think is going to be hugely valuable to the mining industry. In the near term, we've got items like voxel layers, or volumetric pixels. This is going to allow you to explore large multidimensional space-time cubes for different scientific applications. So this is going to open up a lot of potential for 3D and subsurface workflows in geoscience. There's also tools for Python notebooks that are going to be embedded in ArcGIS Pro, and geoprocessing scheduler, which is going to allow you to run those tools, such as the one we created today, on a regular basis, such as a weekly reoccurrence. And one that I think is going to be really big is this interactive suitability modeling at the bottom. For those of you who do suitability modeling, you have to specify all of your model parameters and run the model every time. This is going to, if you want, for example, if you change some parameters, this is going to use raster functions that we looked at today in the beginning of the demo to enable you to have really quick on-the-fly rendering of these suitability models. You'll be able to change your inputs and the weights on them so that you can identify the best places to cite whatever it is that you need to be able to cite. In the midterm, two that I think are going to be huge are presentations. This is going to allow you to create and share collections of maps and scene views along with titles and graphics and descriptive text in these presentations. And GPS support is going to allow you to go into the field and collect data by taking direct position information from a GPS device. And then in the long term, we're adding 3D mesh as something that you can use for a ground surface. And this is going to introduce the ability for you to have really precise and accurate surfaces that can be used for structures such as tunnels and underground mines. So this is going to be really awesome. I think there's going to be a lot of very cool applications in the mining industry. And so there's a lot to look forward to. And that's what I have for you today. And back to you, Pete.
That's great, Matt. Thank you very much. I know that's going to generate some great conversation. So again, I appreciate it and thank you. Now we're ready for a sequence portion of the webinar. So Sarah, if you're ready to go, we'll just go ahead and turn it over to you again to introduce yourself and present away.
Okay, thanks, Pete. And thanks to the Mug and Esri for having us here today. As Pete said, my name's Sarah Deschamps. I'm a product owner with Sequent, and I work on the GIS and geology extensions, some of which we have for Esri products. Today, I'd just like to give you a quick introduction to who Sequent is and why we are building on top of ArcGIS Pro. And I'm going to spend most of the time looking at two of the add-ins that we have available for ArcGIS Pro right now. So, briefly just introducing us, Sequent is a global leader in the development of visual data science software. Sequent's known around the world for...
On the website medium.com, they say software engineers mainly create products that create data, while data scientists analyze it.
Sorry about that. A little technical glitch on my side. Sorry, I'm going to start again. Sequent's known around the world for its Leapfrog 3D geological modeling solutions. First introduced to the mining industry about 15 years ago, Leapfrog helps to uncover valuable insights from geological data and has quickly become one of the main tools in any geologist software toolbox. Geosoft is a geoscience visualization software company that was acquired by Sequent in December of last year. Geosoft is known as the creators of Oasis Montage and of Target for ArcGIS, which is a subsurface drill hole extension for ArcMap. Geosoft created Target for ArcGIS about 15 years ago, and it was then the first mining-focused drill hole and cross-section extension for the ArcGIS platform. Geosoft's been a gold business partner of Esri's for many years and continues to work closely with Esri to design, develop, and launch new extensions for the natural resources sector. Both the Leapfrog and Geosoft product lines continue to thrive as complementary solutions within the Sequent platform, and now we're continuing to deliver essential workflows for geology and GIS professionals on the ArcGIS Pro platform. Geosoft, Sequent, and Esri are working together to help geoscientists all over the world solve earth, energy, and environmental challenges. But why Pro? Geosoft has a long history of building geoscience workflows on top of the previous GIS platform, ArcMap, but obviously the future of Esri is ArcGIS Pro. Our previous software was running on ArcMap, and our customers have been asking us to create a similar solution for ArcGIS Pro. But there's actually several other compelling reasons why ArcGIS Pro is an ideal platform for us to build on. It's modern and easy to use. It's got the new Windows-style ribbon interface, but it's also easy to build on with new SDKs and developer tools and a great partner program that supports us. It's identity aware using named user style licensing, which is similar to what we've used since 2015. It's web enabled, as Matt was saying. It's constantly connected to the Esri Geospatial Cloud and ArcGIS Online for sharing data, for online storage, and for cloud geoprocessing. Two of the most important things, though, about ArcGIS Pro for us was that it's a multi-map project space, not like ArcMap was, a single map document. It makes it much easier to deal with multiple plan maps, section maps, and 3D views that's so common in most exploration workflows. And it has 3D embedded right inside of the ArcGIS Pro application. ArcMap was a 2D only, whereas ArcGIS Pro is a 2D and 3D in a single environment. So all of these differences make ArcGIS Pro well suited to mineral exploration workflows. And let's give you an idea of some of the things that we've been building for ArcGIS Pro. We have two add-ins, one that we released last year that's focused around raster interoperability, and one that's coming out in November of this year that is focused on drill hole workflows. And I'm going to show you both just quickly for the first one. Released in June of 2018 and then updated again in December, the Geosoft Rules add-in for ArcGIS Pro is a free add-in that allows you to import Geosoft rasters or grid files and view them as you would expect to see them in ArcGIS Pro, so retaining their color, retaining their appearance. It also allows you to search for and download free geoscience datasets via the Geoscience Data Portal. The link at the top of the slide here takes you to a story map where you can learn more and download this add-in. I think I mentioned the add-in's free. It works on ArcGIS Pro 2.1 or higher at any license level. There's no subscription required, but you do need to create a Geosoft ID. And since it's mostly focused around interoperability and supporting our raster grid file formats, it's mostly aimed at either existing Geosoft users or the customers of our customers. So anyone who has Geosoft grids or wants to be working with Geosoft grids in ArcGIS Pro. Next, I'm going to show you a sneak peek of the add-in that we've been working on for viewing drill hole data in ArcGIS Pro. This is intended, excuse me, this is intended to replace our previous extension for ArcMap, but it will also be significantly different. Our goal here is to create a replacement for Target for ArcGIS on the Pro platform, but not a carbon copy of our previous extension. To achieve this, we're focusing on 4 main areas of drill hole data, visualization, and display. These 4 functional areas are the cornerstones of our previous product, but the overall approach we're taking in Pro is significantly different since we are leveraging Esri file formats and ArcGIS Pro tools much more extensively. So the 4 areas that we focused on were drill hole data management using Esri geodatabases, drill hole visualization, symbology, and appearance, cross-section creation, and some related workflows, and an embedded subsurface 3D experience within Pro. So I'm going to show you some examples of this now using some videos that I've pre-recorded because the software is in pre-release and not yet totally stable nor finished. So here we are in Pro, and going to be looking at the drill hole tools extension that we've got. The first step is obviously to import some data. We have several different industry-specific imports available, such as Acquire and MX Deposit, and a number of generic methods like CSV, Excel, and Access. The one that I'm showing here is the Access import. So we're selecting a Microsoft Access MDB. And from that database, I'm going to choose the caller table and the survey table, both of which are required. And then any of the downhole data that I want to import and work with inside of ArcGIS Pro. So this could be your geochem assays, your lithology, mineralization, structural data. It could be from to or interval data, or it could be point data as well. And of course, we're going to choose a coordinate system that goes with that data set so that after we've imported, the coordinate system will remain part of the data set. Here, we're basically checking if the fields that are in the tables are being recognized correctly, and if they've got a reasonable name, they're going to get picked up automatically. You might not need to do that step if your names are straightforward. It's going to go ahead and import all of that drill hole data, so about 7 or 8 different tables worth of data out of that ArcGIS database. And when we switch over to catalog, we can see in the file geo database, we now have a feature data set called drill holes and a whole number of feature classes that contain all the drill hole data. So point feature classes for the callers, line feature classes for most of the data sets, and the downhole traces, which are created for you. Another slightly different view of the same data. This is a tool which we've added so that you can see one level down into the feature class. You can see the attributes that are available within each feature class, and when you drag and drop the attribute level information, it'll automatically apply symbology based on that attribute that you dropped. So in this case, I'm dragging over silver assays from my geochem table, and it automatically colors those using the silver values. Same example, but using lithology string data in this one. So that second area that I mentioned was about symbology and appearance. So we have a number of tools that are related to just that, to symbology and appearance. Here we're going to look at the built-in tools. You can, of course, use all of the very rich symbology tools that are available in Pro. You can set up your own look and feel. You can save those as a layer file if you want, but you can also save it as part of the drill hole project so that you can use it going forward when you're creating multiple maps, sections, and 3D views. So here I'm going to save both the color-coded caller information and the nice gray trace lines that I like so much. And those will be available to me the next time I display this data into a new map. Another option we have is to import symbology from existing either layer files, geodatabases, or a Geosoft CSV, which is what we used in our previous software. So I'm going to go ahead and import my rock codes because, as geologists are a little picky about how they like their lithology to show up, they always want to have the same rock codes. They want to have it the same on each map, and they want to have it same across the entire company and all the different geologists in the organization. So here, what I'm going to do is just create a new local scene, and I'm going to go add several different layers of drill hole data just by toggling them on. I'm going to choose my callers and my traces, the silver assays again, and the lithology data. And when I hit apply here, it's going to add all of those layers into that scene for me, but it's also going to apply the default symbology that I just set and selected as my project symbology. So every time I create a map now or a scene, I'm going to get that same appearance, that same symbology being used going forward. And this can save a lot of time when we're working with multiple maps or multiple scenes. The last little thing it showed here was you just quickly clicking on an assay will bring up the pop-up information tool, which shows you the drill hole you clicked on, the from to interval, and all of the assay values for that particular interval. Next, we're going to have a quick look at navigating around in 3D and then creating some cross sections. So here, in most maps and scenes these days, you'll see base maps, and Esri has a huge collection of fantastic base maps that you can add and add a lot of context to your project. But in 3D, they go out to the horizon because they cover the whole globe. And if you're working with subsurface data, or especially in mountainous terrains like this one, it can be hard to see through that base map or to see around that base map. So you could adjust the transparency, which I did at the beginning, or you can also clip the scene down to the extents of the drill hole project so that you can focus in on the area that you're interested in. So we've added in a couple of tools just around this functionality of clipping the scene to the extents of your drill holes, either to the whole project or to a defined 2D area. And this allows you to really easily control what shows up in the scene and how much you see before you start working with the subsurface. It also makes it a little easier to navigate around and rotate and get underneath the surface, which can sometimes be a bit tricky. I'm going to rotate back around to the top, looking at a bird's eye view, and we're going to start creating cross sections. So here we've got a tool for digitizing and creating a new cross section location, which I'm going to define just by creating a box or a rectangle. That appears on the side as a panel where you can see all the properties or the location information of that box. And I'm going to do it one more time here. And this time I'm going to modify the location a bit. So if you click into any of those parameter boxes for the location, a slider appears and you can simply slide the box around in the view and position it more accurately or where you want to have it. So I've created those two sections, saved them as part of my project. Now I'm going to have a look at them in a slightly different way and modify the location to make sure they're just right. I'm turning on the option here to clip the scene temporarily to the section extents. I can then adjust the length of the section so that I can get a better length of the overall map view. And in this one, I'm going to do the same thing, just adjusting the length and the height to kind of squish up that box a little bit. And then saving that will save those sections. I can see all the sections in my project. So here I've got 3 different ones labeled, and I'm going to get into the section viewing tool, which allows us to view those sections from a perpendicular angle and to do a couple other things as well. So here I can see in a drop-down each of the sections that are part of my project. And I'm still in 3D, so I can rotate around or rotate away from that perpendicular view, but it'll automatically snap me back to a perpendicular viewpoint as soon as I let go of the mouse cursor because I've got that lock option turned on. So here I can flip through and check multiple different sections and see if they're in the right location, see if the data is being shown correctly, and that gives me a sense of the data in the project. This tool is still actively under construction, and we're working with a number of our early adopter customers to improve it. So that's something that we're still working on before release. Lastly, I'm going to show you a few things in the subsurface area, bringing in other subsurface datasets. And as Matt was mentioning earlier, there's voxels or block models. 3D rasters are a very common file format in the exploration space. You might have them as a lithology block model. You might have it as a geophysical voxel or a geophysical model. We'd like to be able to bring those in, but right now ArcGIS Pro doesn't have a file format. That's coming soon, according to the roadmap, which is great. But until then, we can bring in slices out of a block model like that. So we can take these slices out of a voxel, out of a 3D raster, and they become a section-oriented raster. And we can drop those into the 3D scene. They show up in exactly the right spot with my drill holes, and life is good. This is actually a tool that you can do right now. You can use right now in the free add-in that's available. You can import section rasters if you have them from another software. The last option here I'm going to show is importing subsurface meshes. So in this case, it could be a geological model, maybe created in Leapfrog, created in Geosoft or another package, and or it could be grade shells as well. And we bring in these subsurface meshes as a multi-patch feature class in ArcGIS Pro, and that then becomes part of your 3D scene and a part of your geo database as well. Here you can see I've got contact surfaces between the different lithologies and then a closed red body around the mineralization of interest. And I'm just going to turn on what happens with that section viewing tool when we click to the section extents. If we've got one of those geological models in the scene, this is the kind of view that you would see there, where you can see the sliced version of the geology. So that's a quick run through of our new extension. It is coming out in November of 2019. Just to summarize, you would have seen Drawable Data Management, visualization and symbology options, cross-section creation and viewing, and some subsurface tools. If you do want to stay in touch, the first link will get you on our mailing list for more information about this new product. The second link there is a chance to learn more about the add-in that we already have. That'll take you to the story map where you can see some more. So thanks very much, and I'll throw it back to Pete.
All right, great, Sarah. Thank you very much. And as with Matt's, I know that's going to drive a lot of positive conversation. So again, thank you. As promised, we do have some time for questions. I'll start with a few over to Matt, and then we'll toss a couple over to Sarah. Matt, well, before I start there, we do have a lot of requests for sharing the task itself, and we're going to work on that and hopefully be able to share the actual task. But the first question to you, Matt, is there any other documentation that exists for best practices when trying to create, share, and maintain the master elevation or master imagery data set? Did you catch that, Matt?
Yeah, so that's a good question. There's definitely some good resources online for that, and I can certainly, after this presentation, I think we'll probably summarize a lot of these questions and I'll provide some links out to documentation on how to do that. The way we're doing it is using Mosaic datasets and image server to serve those out over the web. And so in that Mosaic dataset is a collection, like I mentioned, of all of our imagery products. I was using LiDAR data, and after it gets served out over the imagery through image server, it appears as a raster. And so there's a whole bunch of workflows for managing data in Mosaic datasets and with image server, and we can definitely share those with everybody.
Great, thank you, Matt. And another question to you, Matt. Everybody is very appreciative of the task. It's getting a lot of conversation. What level user can run the task?
Yeah, so the tasks can be used by any level of user, a basic, standard, advanced, and they can also be created by any level of user. So tasks are really open for everybody to create and use, and so you can make them for any workflow that you want. And I would be happy to share those with anybody who's interested in having the ones that I've created here as well.
Okay, and just to reiterate, we will be sharing the answers to all the questions shortly after the webinar. And not a final question, but a third question to you, Matt, again along the licensing. Are there any required license add-ons to perform this type of stockpile calculations? 3D, spatial analysts, things like that?
Yeah, in my task, I used tools that were in 3D Analyst in the 3D Analyst toolbox. So those would require a 3D Analyst extension, and there might even be some in Spatial Analyst. But today, for the ones that I used, it was just 3D Analyst. That would be the only requirement. Okay,
perfect. Thank you. All right, let's get a few for Sarah. Is it possible, Sarah, to you? Is it possible to build a stacked section for this version? Build a stacked section for this version.
Thanks, Pete. It's a good question. It is a tool that we have in the older product target for ArcMap, but no, currently it would not be possible to automatically do a stack section, although I think you might be able to do it using the layouts. It is something I would have to investigate, but you might be able to create a layout with multiple section views on a single page, and that would give you the same appearance as a stack section.
All right, and this is a question I had myself. Will the Geosoft and my Leapfrog IDs be consolidated?
Yeah, great question. Actually, that work is underway right now, and users of either or both should be seeing that change coming out around October, November, late this fall, in the later half of this year. So yes.
Okay. Thank you. We do have a third question for you here. Let's see. Any support for raster borehole logs like acoustic televiewer or optical televiewer?
Yeah, that's also a good question. Not something we have right now. We have looked into that support. If the person who asked that question would like to pop me an email, I know our email addresses are coming up at the end here. I'd be happy to chat with them more.
Okay, perfect. Now let's switch back to Matt real quick. I think we have time for several or a couple questions each. And Matt, how are you managing the imagery and the elevation you pulled into the portal?
Yeah, so a similar answer to that question from earlier, in that all of the elevation and imagery is being managed in Mosaic datasets in a database, either geodatabase or an enterprise geodatabase, and then it's being served out with image server. We can also handle individual images, so mosaic datasets are great as a catalog of lots of images, and it's really effective if you're flying lots of imagery or gathering lots of elevation. But then there was the one other thing that we looked at was a 3D model. So that was a textured mesh, and that was sort of a standalone product, and that was how I was managing that highly performant, like web-ready 3D model.
Okay. Another question to you, Matt. Can the volume tools work on underwater trenches excavated for seabed mining using multi-beam DSMs?
Yeah, this would work pretty much the same with that type of data. It's really data source agnostic, as long as you have that DSM. And if it's a trench and we need to calculate, the inverse of what we did today, that's possible. If we're calculating the volume of a pit versus the volume of a stockpile that goes up, that's definitely something that we can do.
Okay. Now let's do a couple more questions, a few more questions, and send this one over to Sarah. Sarah, when the source data has changed, do you have to import the data all over again?
No, that's a good question. There's an automatic or a single step refresh that you can do. So in the background, we save all the import parameters, and with a single click, you can just refresh the data from the source, and that'll just take a couple minutes, and you'll have all the latest data uploaded.
Perfect. Another question to you, Sarah. Is there a way to plot a series of sections not stacked on separate sheets?
Yeah, I think that would be the same answer, actually. I think you would go to the layout tools in ArcGIS Pro, which are really powerful, and Matt showed a bit of that in his demo. And I believe there's an option in there for a map series or a map book, and you could create a series of sections that way.
Okay, let's keep going with you, Sarah. Which desurveying methods do you use to create the drill hole traces?
Okay. So the collars and the survey information both get used to calculate the downhole traces and the depth ticks, and that uses either a minimum curvature method, or you can do straight segments as well for trenches.
Perfect. All right, let's look to finish up with this question to Matt. Matt, can various obstructions be removed from the volume calculations?
Yeah, so that's something I didn't have time to touch on today, but at 2.4 we released a capability called Pixel Editor. And so if there's, maybe you're calculating the volume of a pit and there's some machinery that's in the pit, for example, you can actually remove that using this Pixel Editor tool. And what you do is you select an area of what you want to replace that excavator with, for example, and it'll just essentially move those pixels over there. And so you can you can remove structures or whatever it is that's obstructing your volume calculation.
All right, perfect. All right, we are very close to the top of the hour, so we're going to wrap things up. If you do have follow-up questions, you're very much welcome to contact us directly by email, or you can visit our LinkedIn site and post a question there. We have presented a lot of material today, so remember this presentation has been recorded, and you'll be receiving an email with a link to the recording in the next few days. Previous webinars in the series can be found on the Mining Webinar Series online library at the link indicated here on the slide. And with that, I want to sincerely thank Chris, Matt, Sarah, everyone who has attended today's webinar, and we're very much looking forward to seeing you on our next webinar, which we will be scheduling and letting you know about shortly. So from Pete Will, thanks everybody, and have a great day.